Standard 11 Chemistry Unit 4 Chemical Bondings and Molecular Structure Part 17. Last time we had discussed about hybridization and the types of hybridization and their examples. Today we are going to learn about molecular orbital theory MOT. As we have already discussed the electronic configuration of the particular atom and the electrons present in the atomic orbital. So here the theory that is very most important, molecular orbital theory, and this theory is developed by R.S. Mulliken and Hund. Let's see about the features of molecular orbital theory. First of all, here the molecular orbital theory developed by Hund and R.S. Mulliken in 1932. The features of this theory is, first of all, the electron in molecule are present in the various molecular orbital, while as the electrons of the atoms are present in the various atomic orbital. That means here, for example, suppose atomic sodium atom and its atomic number is 11. Its electronic configuration is neon 3s1. That means here in 3s orbital one unpaired electron is present. Okay, and then another is the atomic orbital of comparatively comparable energies and proper symmetries combine to form molecular orbital. That means here the atomic orbital of comparable energies means they have nearly about same energy. For another example is first and second features. Here this z axis and the orbitals, here this x axis and its this orbital is on x axis, and here the y axis. So they have proper symmetry and they have almost equal energy, and they combine to each other and forms molecular orbital. Third is, while an electron in atomic orbital is influenced by one nucleus in a molecular orbital, and second it is molecular, it is influenced by two or more nuclei depending upon the number of atoms in the molecule. That means here in simple word, electron in atomic orbital, a what that means here in we can write atomic orbital influenced by one nuclei or one nucleus, and thus atomic orbital is monocentric. It is monocentric. Or electron in bonding orbital, here BO, that means bonding orbitals influenced by two or more nuclei. Here the bonding orbital is polycentric. Here, while an electron in atomic orbital is influenced by one nucleus. In a molecular orbital, it is influenced by two or more nuclei, and that depends upon the number of atoms in the molecule. And an atomic orbital is monocentric while molecular orbital is polycentric. Fourth feature is the number of molecular orbital formed is equal to the number of combining atomic orbital. That means here we can write here fourth feature, number of molecular orbital formed equal to number of combining atomic orbital. If two atomic orbital combine, two molecular orbital is formed. That means here one molecular orbital, and it is called bonding molecular orbital. It is represented by sigma, bonding molecular orbital. And second, that is ABMO, anti-bonding molecular orbital, and it is represented by sigma and this asterisk sign, atomic anti-bonding molecular orbital, BMO. Now what is BMO and ABMO? Here the formation of molecular orbital is described by molecular orbital described by LCAO. LCAO, that means linear combination of atomic orbital. Now let's see bonding molecular orbital, BMO. It is represented by is the sign is psi. It is called psi or described by sigma. Now the molecular orbital sigma is formed by addition of atomic orbital, and it is called bonding molecular orbital. This we can write here psi mo equal to psi a plus psi b. Well, psi is nothing but it is wave function. Then ABMO, antibonding molecular orbital. It is represented by psi asterisk. It is asterisk sign or here sigma. Here the molecular orbital sigma antibonding formed by subtraction of atomic orbital, and it is called antibonding molecular orbital. It is written as psi asterisk, here molecular orbital is equal to psi a minus psi b. So here for bonding molecular orbital, psi mo is equal to psi a plus psi b, and for antibonding molecular orbital is equal to psi a minus psi b, while psi, it is nothing but wave function. So here the formation of molecular orbital is described by the linear combination of atomic orbital LCAO that can be takes place by addition and the subtraction of wave function of individual atomic orbital. And here the psi molecular orbital is equal to psi a plus or minus psi b. Therefore, two molecular orbitals sigma and sigma antibonding are formed as sigma equal to psi a plus psi b, and sigma antibonding equal to psi a minus psi b. Or here we can write a psi molecular orbital and psi antibonding molecular orbital, and this is the formation of the bonding sigma and antibonding molecular orbital by the linear combination of atomic orbitals psi a and psi b centered on the two atoms A and B. Here the atomic orbital psi a and this atomic orbital psi b, molecular orbital, and it is bonding molecular orbital a lower energy than that of the atomic orbital, and here the antibonding orbital higher energy than atomic orbital, and this is the energy level diagram for the molecular orbitals. Here the fifth feature of the molecular orbital theory, that is the bonding molecular orbital has lower energy and hence they have greater stability than antibonding molecular orbital. Sixth feature, that is the electron probability distribution around the nucleus in an atom is given by atomic orbital, and the electron probability distribution around a group of nuclei in the molecule is given by molecular orbital. Last feature, that is very most important, the molecular orbitals like atomic orbitals are filled in accordance with Aufbau principle, obeying Pauli's exclusion principle and Hund's rule. And now is most important for the examination also, conditions for the combination of atomic orbital. You will be asked in the examination also, explain the conditions for the combination of atomic orbital for 3 marks. First of all, first condition is the combining atomic orbital must have same or nearly same energy. For example, here that means one s orbital can combine another 1s orbital, because 1s orbital has same energy, and but not with this 2s orbital. That means here the energy difference between 1s orbital and 2s orbital, and that's why they cannot be combined with each other. But this is not true if the atoms are very different. Second condition is most important. The combining atomic orbital must have same symmetry. Must have same symmetry. Here must have same or nearly same energy. Second, same symmetry. About molecular axis. That means here the atomic orbital that can be combined, here the atomic orbital is on z axis or on x axis. So here only the orbitals on the z axis can combine, or either x axis, means here the second, if second orbital is also on x axis, they can combine. If sidewise overlapping, they forms pi bond. Here the two atomic orbitals are overlapping to each other and they forms pi bond. Okay, is sidewise or side by side overlapping. Or here suppose orbitals on z axis, here the two orbitals combine end to end overlapping. Or orbitals on y axis, they only arranged. Okay, so here by conversion z axis is taken as molecular axis. It is important note that atomic orbital having same or nearly same energy will not be combined if they do not have the same symmetry. Example is here 2pz orbitals, one atom can combine with only 2pz orbitals of the other atom, but not with px and py orbital, because of they have different symmetry. Here the symmetry on z axis and the symmetry on x axis and symmetry on y axis. Fourth condition is most important. The combining atomic orbitals must overlap to the maximum extent. The greater extent of overlap, the greater will be the electron density between the nucleus of molecular orbital. That means here overlapping must be greater extent. Okay friends, so this is the concept about the conditions for the combination of atomic orbital. Number one, they have molecular orbital, they have same or nearly same energy. Second, they have same symmetry. And third is the maximum extent of the overlapping. And next time we will discuss the energy level diagram for the molecular orbital. Thank you very much.